So now,
Good evening, sir.
yes, that's the way you should say good evening. Good. Okay then, right. So now you are seeing two bodies. This is mass M1, this is mass M2. You are seeing two bodies. Can you see two bodies, all of you?
Yes, sir.
Now,
Yes, sir.
good.
Yes, sir.
Now good. Okay. See, now you see this vector, right? This is the now you are seeing just two bodies, correct? All of you?
Yes,
Yes,
sir.
sir.
What is the state? What is the state of motion of each of the bodies?
Rest.
Yes.
They are at rest.
Yes, sir.
Okay? Why do you say it is at rest? Yeah, you obviously, when I am just showing you two bodies and I am not showing any, I have not told anything that is it is in motion, then obviously you will conclude that it is in a state of rest. Excellent. Okay, so now I am going to attach velocity vector to each of the bodies. Can you see here?
Yes,
I am
sir.
attaching the velocity vector to each of the bodies. Okay. Okay. I will call this velocity vector of this one as v1 bar. Okay. And this vector as v2 bar. This is v2 bar and this is v1 bar. Okay. Now, just by inspection, what is the relation? Just by inspection, what is the relation between v1 bar and v2 bar? By inspection, ಅಂದ್ರೆ ನೋಡಿದ್ರೆ ಏನು ಅನಿಸುತ್ತೆ ನಿಮಗೆ v1 bar v2 bar ಬಗ್ಗೆ ಸಂಬಂಧ ಏನದ ರಿಲೇಷನ್ ಏನದ ಜಸ್ಟ್ ನೀವು ನೋಡಿದ್ರೆ ಏನು ಅನಿಸ್ತದ
Sir, V1 bar is the less.
Sir, V1 bar is small than V2 bar.
ಓಕೆ ರುಚಿಕ್ ವೆರಿ ಗುಡ್ ಮ್ಯಾನ್ ಓಲಕ್ಕಿ ಪ್ರಪೋಸ್ ಬರುತ್ತೆ
Thank you, sir.
is it less
No, sir, equal.
ನೋಡಿ ನಿಮ್ ಕಾಣ ಬರೋಬ್ಬರಿ ಇಲ್ಲ ನಾವು both of them are equal. Clear? Hello?
Yes, sir.
Hello? So both of them are equal. Understood? So V1 bar equal to V2 bar. Correct?
Yes,
Yes,
sir.
sir.
Why V1 bar?
Yes, sir.
Now answer carefully. Why V1 bar is equal to V2 bar? Why is V1 bar? Why is it equal to V2 bar? Lagu.
Sir, because the both body has same speed and one direction, sir.
Excellent, shabash. ನೀ ಏನಾದ್ರು ಕ್ಲಾಸ್ ನ ಕೂತಿದ್ದಂದ್ರೆ ಮಸ್ತ್ shabash ಗಿರಿ ಕೊಡ್ತಿದ್ದೆ. Very good. So both the vectors are equal vector. Magnitudes and directions are same. Magnitude
Same.
is speed, direction is same. Both of them are same. ठीक है? Now supposing you see here what I will do. See now here I will take it up. Supposing the velocity of this is like this. The velocity of this I will show it like this. Okay? Now magnitudes are same. Direction is different. Okay? So this one I will write it as V1 bar and V2 bar. Now can I write V1 bar is equal to V2 bar?
No, sir.
Hello?
No, sir.
I can't write. Why?
No, sir, because
Direction
Direction is
Ah,
different.
now you
direction
see.
is changed, but the magnitude is same.
So magnitude is same, direction is different. But now you cannot write V1 bar is equal to V2 bar. Got it?
Yes, sir.
Understood that?
Yes, sir.
Yes, sir.
Yes, sir.
So not only velocity, force vector, acceleration vector, any two vectors if I say they are equal, if I say two vectors are equal in general, okay? So how do I represent a vector? I represent a vector by symbolically like this. What is A bar? Name of a vector. It is a vector. Got it now? That means A bar is a vector means it is a physical quantity. It is a physical quantity. Force, velocity, acceleration, all these are physical quantities. So A bar is a physical quantity which gets completely specified if you specify both its magnitude and direction. For example, A bar, I can see now A bar, supposing I say A bar is velocity. Then what is the magnitude? Speed. Direction, it will have a direction. Got it now? Suppose you say A bar is acceleration. वो नाम में क्या लिखा है? A bar is acceleration. That means its magnitude is the acceleration and direction as it is. Supposing I say A bar is force vector, then magnitude is the amount of force and it has some direction. Got it now? So in general, A bar is a vector. Okay, it will be specified only if you specify both its magnitude and its direction. right? So you should say, oh, this body, velocity of this body is v1 bar. That means I should tell the speed of the body is so and so and its direction is so and so. Got it now? Now, if I say a bar is one vector, are you understanding?
Yes, sir.
And I want you to retain this. I will not give any notes. It should be in your head.
Yes, sir.
Huh.
Yes, sir.
So I will write another vector v bar. So what is v bar? Some vector. Hey, velocity it is another vector. In general, in general, understood? See, he is a boy. In general, no. Consider a man. In general, we'll tell no. Then you say this man is that person, that man is this person. Then you are assigning somebody. Got it now? So a bar is some vector, b bar is some vector, some other vector. Got it now? Now, if I say a bar is equal to b bar, then what is your inference?
So its magnitude and direction is same.
Its magnitude and direction is same. Very good. Like this you should answer. But one more condition I will tell. Its magnitude and direction is same. One more thing. Both of them are of same kind. Andra, for example, ನೋಡಿ ಈಗ ಒಂದು ವೆಕ್ಟರ್ ಬರುತ್ತದೆ. ಇದು acceleration ವೆಕ್ಟರ್. ಇನ್ನೊಂದು ವೆಕ್ಟರ್ ಬರುತ್ತದೆ. ಓಕೆ? ಇದು F1 ಬಾರ್. ಫೋರ್ಸ್ ವೆಕ್ಟರ್. ಈಗ ಸೈಜ್ ಎರಡಕ್ಕೂ ಸೇಮ್ ಐತಿ. ಡೈರೆಕ್ಷನ್ same ಐತಿ. Now you cannot write A1 is equal to F1. Got it? Hello, you cannot write simply. See, these two magnitudes must be same, direction must be same, and they should be of same kind. Andra, idu velocity idre idu velocity irbeku. Idu force idre idu force irbeku. Atadala?
Yes, sir.
So when I write A bar is equal to B bar means they are vectors of same kind. Andra, they are representing same kind of vectors. Andra, force idre force, velocity idre velocity. Tiritala?
Yes, sir.
That is what you have to understand. Okay, very good. So therefore now students, what we will try to understand here is in this whole setup, what we will try to understand is that so now if I say that if I am attaching, see what am I doing now here? I am associating velocity vectors with the two bodies. The mass of this body is m1, the mass of this body is m2. Got it? I am assigning the velocity. Understood? Now, looking at it, what do you feel? What is that feeling you get? What is that imagination you can do? See, I want you to imagine the reality. What are you imagining?
So there are two bodies.
There are two bodies. Now see, what you are imagining?
With mass m1 and m2.
With mass m1 and m2.
They are moving with equal speed and equal direction.
Yes, or same velocities. Now, you don't have to tell separately. Both are moving with same velocity. Got it down?
Yes,
Huh. So, and any other thing that you can compare these two? You said m1 and m2. Now look at the figure and tell. m1 is less than m2. Hello, can you not see? ಅಂದ್ರೆ ನಾನು ಏನು ಕಲಿಸ್ಲಿಕ್ಕೆ ಪ್ರಯತ್ನ ಪಡತ್ತೇನೆ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ರಿ. ಈಗ ನೀನ್ ಬೇರೆ ನಾನು ಹಂಗೆ ಸಾವಿರಾರು ಹುಡುಗರು ಇರ್ತಾರೆ. ನೀವು ಆನ್ಸರ್ಸ್ ಬರೀತೀರಿ. ಪೇಪರ್ ಒಳಗೆ ಬರೋದೇ ನೀವು ಕೊಡ್ತಿರೋದಿಲ್ಲ. ನೀವಂತೂ ಇದು ಇರುವುದಿಲ್ಲ. ಯು ವಿಲ್ ನಾಟ್ ಬಿ ಇನ್ ಫ್ರಂಟ್. ಯುವರ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ represents what you have understood. Okay, so you have to imagine the reality and represent it on the paper. Or something is represented, you should you should infer from it. So what is the inference you get from this? You have got two bodies. One body's mass is m1, another body's mass is m2, and both have got same velocities, vectors. So therefore, both are moving with same velocity. There, one body is a big body, one body is a small body. See, this can be a bus and this can be a auto rickshaw. So we don't have to draw bus and auto rickshaw. We are showing it by some shape like this, and conveniently it is spherical shape. Correct?
Yes, sir.
Right. And I don't have to show it like this. As you know, I can show this m1 by one small dot, m2 by small dot. I don't have to even show like this. But if I am capable of showing like this, then it is evident that it is bigger, it is smaller. Okay, na? So you should try to understand things like that. Okay? Hello?
Yes,
Yes,
sir.
sir.
Then,
Yes, sir.
good. Right. Now, both are moving, right? So what will I do now? I will now take a force vector. and keep it here. Right? I will take a force vector and keep it here. Right? And I will also take another force vector and keep it here. Right? Now you see here, I am applying force to this body. I am applying force to this body, F1 bar and F2 bar. Now look at the two forces. Same magnitude, same direction. So F1 bar is equal to F2 bar. Right? Now I applied the force at time t1. To both the bodies, I applied force at time t1. Got it?
Yes, sir.
Then I continue to apply force for time t2. I continue to apply force from time t1 to t2. What happened?
The speed increased, sir.
Speed of both increased?
Yes, sir.
Only speed increased?
Sir, note the direction. Speed increased of both in same quantities, sir.
Speed increased in same quantity, both of them. What about the direction?
Sir, direction was same, sir.
What do you have to say?
So, the force applied in,
Louder.
So the force applied in the first body will be more and the force applied in second body will be less.
No, I applied same force, no. See, I told you here, F1 bar is equal to F2 bar I wrote, no. That means magnitude is same. Force applied is same, because the vectors are same.
So force applied is same, but motion is changed. The big body or the body which has more mass is moving slow, and the body which has less mass is moving fast.
Beautiful, beautiful, wonderful. That is abstraction. Now you have just used the one concept wrong. Your imagination is correct. So what will force do to a body? What will force do to your body? Good answer, but slightly mistake you have done. What will force do to your body?
It will change the state of motion.
See, in this particular case,
It will accelerate.
it will accelerate. Use the right concept, Rutvik. See, when you apply force to both the bodies, now the only one force is acting on both the bodies.
Yes, sir.
So that itself is the net force. So what will force F1 bar do to M1? It will accelerate. What will F2 bar do to M2? It will accelerate. Got it now? Hello?
Yes, sir.
So these forces will produce acceleration. Acceleration means what? In this case, it will increase the velocity. In this case, can you see?
Yes,
See, in both the cases, the velocities are increasing. Hello?
Yes, sir.
Now here in the first case, what is the acceleration? How much is the acceleration?
F by N.
A, F1 bar by M1. Hello?
Yes, sir.
Yes,
What is the acceleration in the second case?
F2 bar by
F2 bar by M2. Got it?
Yes, sir.
Now here I will make a proposition. What is that? F1 bar is equal to F2 bar is equal to F1. Some common. What is that telling? That I have got two different forces, but both the forces are equal to F1. Means what? Each of the force has same magnitude and same direction. So I can now write this equation as what? F bar by M1. I can write this equation as F bar by M2. Got it?
Yes, sir.
Now you see, you can compare these two equations. See, in both the cases, the numerator is same. Hello?
Yes, sir.
Only the denominator M1 is now less than M2. So what will happen to acceleration A1? What is the relation between A1 bar and A2 bar?
So the acceleration in M1, in the body M1 will be more.
ಇಲ್ಲಿ A1 bar ಬರ್ದೇನಲ್ಲ ಹೇಳ ಕರೆಕ್ಟ್ ಆಗೈತಿ ಅದು ಬರೋಬ್ಬರಿ ಹೇಳ
Sir, acceleration A1 bar is greater than acceleration A2.
acceleration A1 bar is greater than acceleration A2. Got it, no?
Yes,
Yes, sir.
See, we can experience it, no? See, one big body is there, one small body is there. You are applying same force. So, one big ball is there, one small ball is there. I push. I am applying same force. With left hand, F1 bar, F2 bar. F1 bar and F2 bar are same. But what happened? Small body accelerated more. Big body accelerated less. See, one
It is
small,
more, but big body doesn't
yes,
accelerate
one
as
small,
much as the small body.
one small ping pong ball is there, one football is there. You apply same force. Ping pong ball will have more acceleration. Football will have less acceleration. It is common sense, no? Isn't it? Same common sense I am showing here. Whatever is the truth, no, I am showing it by picture and mathematical model. Did you get it?
Yes, sir.
So I have applied same force to both, but since the mass here is less, acceleration is more. Since the mass here is less, acceleration is less. Got it?
Yes, sir.
So now I will write in general. Acceleration is inversely proportional to mass. Agreed? Okay. Acceleration is inversely proportional to mass, provided same force is active. This is the symbol. What does the symbol say? Acceleration is inversely proportional. Inversely proportional ಅಂದ್ರೆ ಏನು? ಇದು ಜಾಸ್ತಿ ಆದ್ರೆ ಇದು ಕಡಿಮೆ ಆಗುತ್ತೆ. ಇದು ಕಡಿಮೆ ಆದ್ರೆ ಇದು ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ನೋಡಿ, ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಅಂದ್ರೆ ಏನು? See now. A is directly proportional to M. ಅಂದ್ರೆ ಏನು? Mass ಜಾಸ್ತಿ ಆದ್ರೆ acceleration ಜಾಸ್ತಿ ಆಗುತ್ತೆ. But is it happening here like that?
No, sir.
It is happening what ulta?
Yes, sir.
More mass, less acceleration. Less mass, more acceleration. Got it now? So I am using the inverse relation. And what is the symbol I am using? I am drawing a big line and saying F bar. Means what? For the same force. That is, force is constant. See here, in both the cases, force is same. Only difference is mass is changing. Hello?
Yes,
Yes,
sir.
sir.
And therefore, acceleration becomes inversely proportional to mass. Got it?
Yes,
Yes,
sir.
sir.
You have any question, any doubt? Any doubt? See, I am telling you children, these are all concepts. It is for you, it is difficult. Why it is becoming difficult? Because 2 years of COVID, you are not in the proper learning mode. You had by-hearted some things. And somehow you passed your 6th standard, 7th standard. Okay, I pity you. So don't worry. But that should not be the cause. Every time, you cannot ask everybody to be sympathetic to you. ಹೌದ್ವಾ ನಮ್ಮ ಮಗಳು ಕೋವಿಡ್ ಬಂದಿತ್ತು ಅದಕ್ಕೆ ಆಕಿ ಶಾಣ ಇಲ್ಲ ಅಂತ ಹೇಳ್ಕೊಂತ ಹೋಗೋಕೆ ಆಗುದಿಲ್ಲ. ಬಿಕಾಸ್ ದೇರ್ ಆರ್ ಲ್ಯಾಕ್ಸ್ ಆಫ್ ಸ್ಟೂಡೆಂಟ್ಸ್ ಇನ್ ಸ್ಪೈಟ್ ಆಫ್ ಕೋವಿಡ್ ದೇ ಆರ್ ಡೂಯಿಂಗ್ ವೆಲ್. ಓಕೆ, ದೇ ಡಿಡ್ ನಾಟ್ ಡೆಟರ್. ಓಕೆ, ಕೇಬಿಡ್ದಾರ ಬರಲಿ ಏನಾರು ಬರಲಿ, ನಾ ಅಂತೂ ಬರೋಬ್ಬರಿ ಅಭ್ಯಾಸ ಮಾಡಿ. ದೇ ಆರ್ ಸ್ಟೂಡೆಂಟ್ಸ್ ಹು ಹ್ಯಾವ್ ಡನ್ ದಟ್. ಓಕೆ, ಸೊ ಯು ಹ್ಯಾವ್ ಟು ಕಾಂಪೀಟ್ ವಿತ್ ದೆಮ್. Understood? So better be prepared for the competition. Now your duty is very simple. If you are not understood something, you should simply tell, sir, I didn't understand. I will peacefully teach you. I will not scold you. If you want me to repeat everything, I will repeat once again. What you didn't understand? See everything. Yes, this is the final conclusion. Okay? The conclusion is this. I told all this because of this. Acceleration is inversely proportional to mass, provided force is same. Andra, idea of this is what? You can take different masses, M1, M2, M3. Take different masses. Okay? And you apply same force to all the masses. What will you see? Different accelerations. Got it? No? That is what it is telling. Okay? And I have associated velocity vectors. Now this is precisely what you have to do. As soon as I tell you there is a body in motion, then before your mind's eye this should come. One point should come, velocity vector should start coming. Okay?
Yes,
Yes,
sir.
sir.
Okay, fine. Right. Now I will ask you one intelligent question. You should answer. Ready? Hello?
Yes, sir.
Yes, sir.
Let me see how well you answer. Okay? So now you see I have applied. See here, what you see here is at the time for time between time t1 to t2. Okay, I am applying force F1 bar here. I am applying force F1 bar. What does it mean? I am applying same force to both. Equal force. And I will say this is V1 bar and I will say this is also V1 bar. Any problem?
No, sir.
Correct now? Understood now?
Yes,
So
yes, sir.
what do you do now? V2 bar very agree? Yeah, there is a velocity vector V1 bar. It has got some magnitude and some direction. I can use it for 100 bodies. If there are 100 bodies having same velocity, I will attach. What is the problem? You one thorn, one the hachbo kantirilla. This is not shirt and pant that obra hakobekantala. This is a concept. You can put it separately. Understood? Stupid ideas, stupid examples. Okay. So I am attaching same. Both are conditions are same. See, what is the state of motion of this, and what is the state of motion of this? Both are same. Right? So both are same. Okay. And from T1 to T2, I am applying the force F1. So what happens from T1 to T2?
So both the bodies accelerate.
Both the bodies accelerate. Okay. Now at T1 the velocity was v1 bar.
Yes, sir.
Yes, sir.
Got it?
Yes, sir.
So at T1 the velocity was v1 bar. So from T1 to T2 you have applied force F1 bar.
Yes, sir.
Now at the end of T2, what is the velocity of this?
V1.
So you didn't understand. See, now you didn't imagine. See, what you did is you saw this and you shouted some answer. Yes, anybody? Can you imagine what I did? So there is a body. Hello?
Yes, sir.
Its velocity is v1 bar.
Yes, sir.
Time is t1. I started applying force. Till time t2. I left my hand. Got it?
Yes, sir.
At the end of t2, what is the velocity of this body?
Sir, the velocity will be more.
Velocity is more, no?
Yes,
Common
sir.
sense will tell you, no?
Yes,
Yes,
sir.
sir.
Then he shouted v1 bar. Height. So its velocity will become v2 bar. Correct?
Yes, sir.
Yes, sir.
Common sense should have told. You should see. Mathematics you should use to represent the reality. Understand? See, you leave that school habit, shout some. See, in your school you shout some answers. Your teacher doesn't bother. Okay? Somebody will shout the right answer. So you have shouted the wrong answer. Nobody will reprimand you. So don't be in that. I am going to reprimand you. Right? Be in that mood. Got it? And if you don't answer also, I will shout at you. Understood?
Yes, sir.
Okay, so the velocity will become v2 bar. And v2 bar is definitely greater than v1. Howdilla?
Yes,
Now, what happens to this body? See, for the same thing I did for this body. So at the end of T2, what happens? Think and tell. Aryan Rutvik, you also answer. At the end of T2,
Sir, it will become V2 bar.
it will also become v2 bar. What about Rutvik? What about Pritam, Prithvi?
Sir,
Sir, it will also become v2 bar.
sir, but it's not equal to that first one V2 bar, sir. That's
ಹಂಗಾರೆ ಬೇರೆ ಹೆಸರು ಕೊಡಕ್ ಬರಂಗಿಲ್ಲ ನೀವು ಬೇರೆ ಹೆಸರು ಕೊಡಲ್ಲ v2 ಬಾರ ಯಾಕೆ ಕೊಡ್ಬೇಕಾ ನಿಂಗ್ ಬುದ್ಧಿ ಮತ್ತ ನೋಡು ಗುಡುನ್ ಗುರ್ತೈತಿ ಗುಡ್ ಯು ಹ್ಯಾವ್ ಮೇಡ್ ಎ ಜೆನ್ಯೂನ್ ಮಿಸ್ಟೇಕ್ ಅರ್ಥ ಅದಲ್ಲ ಸೊ ದ ವೆಲಾಸಿಟಿ ಆಫ್ ದಿಸ್ ವಿಲ್ ಬಿ v3 got it?
Yes, sir.
That's all. And v3 bar is greater than v1 bar. Got it? Hello?
Yes, sir.
So you got the idea? Hello?
Yes, sir.
Yes, sir.
Now see, this is how you should learn. See, you should start using your brain and you should be brave. Don't be afraid of giving wrong answer. See, he gave a wrong answer. It is okay. I shouted at him. Shouted andre papa preethile boy. And Aryan also gave one wonderful answer. Hange naditade. It's all genuine mistake. Now you see, now you should be happy that you are talking of velocity vector, acceleration vector, all great things you are talking. See, now you see yourself now. You are like this, you are at this level. Now you are already at this level. You are able to speak all these things. Great. Okay, here and there you are making mistakes. Chalta hai. See, we all learned how to walk. How did we learn? You remember? See, one day, we were doing Ambegal and one day we got up and we tried to hold something. Tabakne fell off. We cried. Then our parents did not say, Nee yaddro bilti jigundag yadda nindirbara antidra makonde irtidi. They allowed you to get up. Then again you fell. Then one day you were able to stand. And then after standing, what you did? You started walking. And then again you fell. Again your parents came and said, oh, you be naditate to go. Again they allowed you to walk. You got up to walk, you fell. You got up to walk, you fell. But It happened. But one day you are able to walk. Till that point, okay, and afterwards you only learned how to run. Your parents might have helped you to stand up and walk, but running they did not teach you. You only learned how to run. But you know, same way physics. So you try to answer, you will do wrong. Chalta hai. I will correct. Again you try to answer. You will do wrong. I will scold you. Okay, again do. Finally you will learn. And I will teach you only some things. How you learn how to run, you will learn lot of physics by yourself. I don't have to teach. You will now learn how to learn from book. See now, Aryan made a genuine mistake. He thought only V2 bar. You can say, see, nim tala yen guttena, idu T2 idre V2 irabekanta irate. Tala yen bitkobedu. T2 andre aa time ge hesaru kotteni. V3 ani innond hesaru kotteni. Nim tala hesaru bere bere illene. Illene.
Yes, sir.
ಈಗ ನೋಡಿ ಇವರಿಬ್ರು ಟ್ವಿನ್ಸ್ ಅದಾರ ಟ್ವಿನ್ಸ್ ಅದಾರ ಅಂತ ಒಂದೇ ಹೆಸರು ಇಡಕ್ ಬರ್ತೈತೇನೆ ಬೇರೆ ಬೇರೆ ಇಟ್ಟಾರ ಹೌದಿಲ್ಲ ಹಾ ರೈಟ್ ಅಂಡರ್ಸ್ಟುಡ್
Yes, sir.
Yes, sir.
now I shall ask you the next question.
Yes, sir.
You will think and answer bravely. So now you told this V2 bar is greater than V1 bar, V3 bar is greater than V2 bar. Now what is the relation between V2 bar and V3 bar? What is the relation between these two? Think and answer. You should go in steps. Both of them both of them had same velocity v1 bar at time t1. From time t1 to t2, both of them same force is applied. One body is m1, another body mass is m2. m1 is less than m2. Both have got accelerated, but the acceleration of this is a1 bar, acceleration of this is a2 bar. a1 bar is more than a2 bar. And as a consequence, the velocity of first body becomes v2 bar. The velocity of second body becomes v3 bar. And v2 bar is greater than v1 bar. v3 bar is greater than v1 bar. Both have got different accelerations. Now, which is moving faster at the end of t2? First body is moving faster or second body is moving faster?
First one.
Common sense. So what is the relation between v2 bar and v3 bar?
V2 bar is greater than V3 bar.
That's it. Got it?
Yes, sir.
Now are you able to relate?
Yes, sir.
See what all you are doing here. एक हकीकत है, एक हो रहा है, रियलिटी में हो रहा है, उसको आप बयान कर रहे हो, उसको आप मैथमेटिकल मॉडल बना रहे हो. ठीक है? इसी को कहते हैं फिजिक्स. Got it, all of you?
Yes, sir.
And I wish you also had answered. You also had answered. Everybody would have shouted together, chorus, and shout. Right? Did you understand now? Hakika? Hello?
Yes, sir.
Ready?
Yes, sir.
Now the next journey will start. Ready, all of you?
Yes, sir.
ठीक है? Okay? Hello? Any questions here?
No, sir.
So this green color will indicate acceleration. ठीक है? Hello?
Yes, sir.
This green color will indicate
Yes, sir.
acceleration vector. Huh? So I am going to associate acceleration vector for this and acceleration vector for this. Now you saw that I copied this vector, I got this here. Got it? You saw that? So what is, how do you see this and this? Both are equal and they are representing acceleration. Hello? Now what I will do, you should see. Okay? So what I will do here is, I will do like this. So what did I do? So green represents acceleration. So blue represents velocity vector. Right? F1 pink represents force vectors. So now I have assigned acceleration vector to both. What is the mistake in this?
Sir, force is equal, but the acceleration is more. Sir.
For which?
Sir, for first body acceleration is more. Sir.
Very good. So that is the mistake. Excellent. This is how your examination is going to be. So this acceleration should have been moved. But it brilliant. And this I expect everybody should have answered. Correct now? Now is it correct?
Yes, sir.
Understood now? So one vector ಮೇಲೆ ಇನ್ನೊಂದು vector ಬರೆದ್ರೆ ನಡೆಯುತ್ತೆ. One vector ಮೇಲೆ ಇನ್ನೊಂದು vector ಬರೀರಿ ನಡೆಯುತ್ತೆ. ಏನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. ತಿಳಿದಾ?
Yes, sir.
ನಮಗೆ ಏನು ಬೇಕಾಗಿತ್ತಪ್ಪ? Now you see, okay. So this is acceleration vector a1 bar, this is acceleration vector a2. And now it is very clear, a1 bar is greater than a2. Clear? So this is how you see, you will make a vectorial diagram. फोर्स वेक्टर भी है, वेलोसिटी वेक्टर भी है, एक्सेलरेशन वेक्टर. ठीक है? हेलो, got it?
Yes, sir.
हाँ. So this is, I have shown all these vectors at time t1. This is at time t1. Got it? हाँ.
Yes, sir.
So in between t1 and t2 there is say some time t3. No, t3 should come after t2. Like हम t2 को बैठ गए. I can give any name to anybody, no? The instant of time between t1 and t2, I can give any name. I am giving the name t3. Got it?
Yes,
हाँ. Now t3 is after t1. So at t3, what changes should I do in these two diagrams? See, now what I have shown is all these vectors I have shown is at instant of time t1. Now what should I do at instant of time t3? What changes should I do in these vectors?
Sir, length.
ಯಾತರ ಲೆಂತ್ ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ 1 ವೆಕ್ಟರ್ 2 3 4 5 6 ವೆಕ್ಟರ್. At time t2, what should have? What is that change I have to do? Wait, she wants to tell.
So the length of the acceleration vector.
ಅರೆಮ್ಮ acceleration ಅಂದ್ರೆ ಏನಮ್ಮ?
So we should just reduce the length.
ಅಲ್ಲ, acceleration depends upon what?
So change of velocity.
Change of velocity actually, but acceleration ಹೆಂಗ ಆಗ್ತದೆ body? How will the body get accelerated? How will you accelerate the body? See, there is a body. How will you accelerate it?
So when force is
When you apply force, no. So you have applied force, it will accelerate. How the? Correct. You have applied force, it will accelerate. All of you agree?
Yes, sir. Yes, sir.
What is the relation between force and acceleration? What is the relation between acceleration, force and mass? What is the relation? What is the relation between all these three? See, I have been writing all this so many times.
So if the
Hey, thadiyo. ಇಲ್ಲಿ ಹರ್ಷಿತ ಹೇಳಾಕತ್ತ ತಡಿ. ಹೇಳು. What is the relation between acceleration, force and mass?
so if the mass is more, the acceleration will be less.
So you should tell acceleration is equal to force upon mass. ಹೌದಿಲ್ಲ?
Yes, sir.
ಹೌದಿಲ್ಲ? ಈಗ ನೋಡಿ. ಈಗ force is F1 bar. ಹೌದಾ? ಈಗ at time t1 ನ force is F1 bar. Mass is m1. Acceleration is a1. ಹೌದಾ?
Yes, sir.
Yes, sir.
At time t2, what has changed? Force has changed.
Yes, sir.
Right? I told from t1 to t2, force is same. Here, force has not changed, no, at time t2. Mass has changed.
No, sir.
Then these two have not changed. This will change. Acceleration will not change now. Hello, got it now?
Yes, sir.
So, from time t1 to t2, force is same, mass is same. Therefore, acceleration is same. Got it?
Yes, sir. Yes, sir.
From time t1 to t2, force is same, mass is same. So, therefore, acceleration will be same. Acceleration means what? The body speed is increasing, no?
Yes, sir. Yes, sir.
Got it?
Yes, sir.
Now you tell me. At time t1, I am showing you these vectors. These vectors I am showing you at time t1. Got it?
Yes,
Yes,
sir.
sir.
Now at time t3, what is t3?
Instant of
Instant of time after t1.
Yes, sir.
See, between t1 to t2, I am applying force.
Yes, sir. Yes, sir.
So at time t3 is in between t1 and t2. What changes should I do in these vectors? Which vector will change? Will this vector change? Hello?
no, sir.
Because I told this is same.
Yes, sir.
Yes, sir.
Will the acceleration vector change? Will the acceleration vector change at time t3?
No, sir.
Why? Why it will not change? Because at time t3, force and mass are same. Yeah.
Yes.
See, you should relate like this. See, my dear students. See what has happened. You have stopped using your brain, or because of watching mobile videos and all. No, your brain is now junk. Start using it. Good. Some students use ಮಾಡ್ಲಿಕ್ಕೆ ಎಲ್ಲರೂ ಮಾಡಬೇಕು. ನೀನು ಅಷ್ಟೇ. So at time, see, this vector has not changed at time t3.
Yes, sir.
Okay. And this also has not changed. And therefore, this vector will not change. Green color, acceleration vector will not change. So force vector has not changed, mass has not changed, so the acceleration vector will not change. Got it? Acceleration means what? Velocity is changing. So which vector has to change? In this diagram, louder.
Velocity vector.
Only velocity vector has to change, isn't it?
Yes, sir.
Hello. So here I should change this velocity vector. Correct? So velocity vector will now start changing. Why? Because the body is accelerating. And why it is accelerating? Because force is acting. And what is the relation between force and acceleration? Then acceleration is equal to force upon mass. Are you able to connect all of them?
Yes, sir.
Okay. Now, who will tell fatafat all this? Whatever I told. Fatafat. Come on. Who will take the challenge? No. Those who take challenge, then you will get good marks in final exams. Those who don't take challenge, then you should not blame the society. You will go to Dabba college. You want to go to good college? Then you answer. Come on, take the challenge. Come on. See, if you take see, I am telling you, if you want to win the race, then you should run. If you sit in the gallery and watch, then I will say, okay, now if you sit in the gallery and watch somebody running, then you will not win the race. Come on. Who will explain? In Indian explain money, yes. I hear.
Sir, math concept.
I hear.
Sir, there is two bodies, sir. First body has less mass, second body has more mass. So when the force is applied to the two bodies in same quantity, the first body will move, accelerate more, sir, because that there is a because the body's mass is very less, sir. The second body, if same amount of force is applied on second body, it will accelerate less because the body's mass is high, sir.
Good. Then, tell.
And when you apply force till T2, after T2 the acceleration will be more.
Hey, you stop. See, I applied force from T1 to T2. Means I applied force from T1 to T2. After T2, I did not apply force. So tell.
Sir, after T2, force velocity will increase, sir.
See, now listen. I have taught you. You should tell only truth. ಬರೀ ಸತ್ಯ ಮಾತಾಡೋದು ಕಲಿಸೇನೋದಿಲ್ಲ ನಿಮ್ಗೆ ಸತ್ಯವನ್ನು ಬಿಟ್ಟು ಬೇರೆ ಮಾತಾಡೋದಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರಲ್ಲ ನೀವ T2 ಆದ್ಮೇಲೆ ಏನಾಗ್ತೈತೆ ಅಂತ ನಾ ಏನಾರು ಹೇಳೇನಿ ನಿನಗೆ ನಾ ಹೇಳೇನ ಮತ್ತೆ ಯಾಕೆ ಹೇಳಕತ್ತ ಹೇಳ್ಬೇಡ ಹೌದಿಲ್ಲ ಈಗ ಏನಿದ್ರು ವಿಚಾರ ವಿಮರ್ಶೆ ನಡೀತಿರೋದೇನ T1 and T2 ಬಿಟ್ವೀನ್ T1 and T2 ಕರೆಕ್ಟ್ Aryan, you are a wonderful student. You correct ಹೇಳಿ ಎಲ್ಲ ಮಸ್ತ್ ಹೇಳಿ very good. Only thing is T2 at T2 you stopped applying force. Got it?
Yes, sir.
At T2 you stopped applying force. Then at T2 you stopped applying force. So when you stop applying force, here what changes should I do? Here, what changes should I do here? After T2, what changes should I do? I stop applying force. What should I do here? I stop applying force after T2. What changes in this diagram should I do?
Sir, remove the force bar.
Remove the force bar. Very good. Very good. So remove the force bar.
Sir, may I answer?
Yes, tell. I will remove the force bar after T2. Okay. Then what else should I remove? When force bar is removed, what else should I remove? Hey, Dhanagol.
Acceleration.
So I should remove the acceleration vector. Got it now?
Yes, sir.
Right?
Yes, sir.
I should remove the acceleration vector. Right? Then at T2, this velocity vector, what will happen to velocity vector? It would have increased. Yes or no?
Yes, sir.
It would have increased. This velocity vector would have increased. Got it?
Yes, sir.
Yes, sir.
Okay. Same thing here. This velocity vector would have increased. Right? Hello?
Yes, sir.
Yes, sir.
So now you can see that this has increased more than this. Understood now?
Yes, sir.
This is at the end of T2. Correct? So this is the diagram at time instant,
T2.
at the time instant T2. Correct?
Yes, sir.
Yes, sir.
Now at some other instant T4, at some other instant T4 is greater than T2. Andre T2 ಗೆ ನೀನು force apply ಮಾಡಿ ಬಿಟ್ಟಿ ಕೈ ತೆಗೆದಿ.
Yes, sir.
Now your clock is ticking. Now at T4, what should I change here? So at T2 you stopped applying force.
Yes.
Then what happens to the body?
Sir, smooth road ಅದನ್ನ
Smooth road. See, ಏನು ಹೇಳಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಸ್ಮೂತರ್. ಏನು ಹೇಳಿಲ್ಲ ಅಂದ್ರೆ ಸ್ಮೂತರ್. ರಫ್ ಇದ್ರೆ ಹೇಳ್ತಾರ. ಏನು ಹೇಳಿಲ್ಲ ಅಂದ್ರೆ ಸ್ಮೂತರ್.
Sir, then the body will, the
Sir,
body
it will continue to move in uniform velocity.
Excellent. It will continue to move in uniform velocity. The best possible answer. Brilliant. Because after T2 you did not apply any force. The body has not accelerated. Velocity will not change. Velocity will change only if you apply force. If there is net force. That is the best answer. Got it now? See, now you see, Rutvik is able to use these concepts and give the answer. Understood? So you should also use these concepts and give the answer like this. That's all. It is not difficult. It is very easy. But you should attempt to do like this. Then you will do. Correct? See, now what I am happy is answers are given by you, not me. And if one student is giving answer, that means everybody can give answers. Okay, so far I used to give answers. So, ನಿಮಗೆ ಗೊತ್ತೈತಿ ನೀವು ಹೇಳಕತ್ತಿ. ನೀ ಏನು ದೊಡ್ಡ ಟಕಲೆ ಆಗಿ ಹೇಳ್ತಿ. Okay, but now you see your own friend is telling you. That means you can also tell. You should get that confidence. Now that means it is not difficult. Correct?
Yes, sir.
Huh? So understood now how to use these vectors, vagara and all? Huh?
sir.
Huh.
Yes, sir.
But here I am only telling you the body is moving in straight line. But frankly speaking, body will not always move in straight line. It can move like this and all. We'll discuss that in the next section. That is, now we are discussing what? One-dimensional motion, straight line motion. Got it?
Yes, sir.
Okay. Now are you ready, all of you?
Yes.
This is the velocity vector v1 bar. This is the velocity v2 bar. At the time t1. Got it?
Yes, sir.
What happens at time t2?
So they continue to move in same velocity.
They continue to move same velocity because I have not shown any force vector. Simple. Got it?
Yes, sir.
Excellent. So at time t1, this is the state. Okay. Now everybody will get this, don't worry. Everyone will be able to answer. Now you see. Now what are these two vectors? Now what is F1 bar? F1 bar. I have applied the same force to. Correct? At time t1. Hello?
Yes, sir.
And I will apply these force vectors from time t1 to t2.
Yes, sir.
I will apply these force vectors from time t1 to t2. Correct?
Yes, sir.
Now,
Yes, sir.
now at the end of t2, what will happen? At the end of t2, what will happen? Tell. Priti,
So it's get accident.
it will get accelerated. So what is the change I should do here? Hello Vijay.
Sir, the length of the acceleration bar should be reduced.
There acceleration bar, I am showing you velocity bar acceleration.
Velocity bar.
Tight. So and yes, at the end of t2, this vector I should be doing this. Correct now?
Yes.
So this vector I should make it this. Correct? And what about this vector? This also I should make it this.
You said it should be less but bigger than the first body.
Huh?
So it should be less but not
Yes, good. I like that. So it should be lesser than before, but it should not. It will not be so. See the amount of length I decrease, but same length I will not decrease. I will decrease lesser because acceleration is less here. Understood now? See how the velocity vector is controlled by force. Force ज्यादा किया velocity rate increase हुआ. Force इस तरफ खींचा velocity vector कम हुआ. है कि नहीं?
Yes,
आप ऐसा महसूस करना चाहिए. ये हकीकत है. ठीक है? आपका दिल और दिमाग लगाने से ऐसा महसूस हो सकता है. सिर्फ दिल दिमाग लगाने से नहीं होता. दिल और दिमाग दोनों का इस्तेमाल करना. जान गए तुम लोग कैसे? ना? So understood now? See the think of forces वगैरह. ठीक है? हाँ हाँ. Fine. So I think by this much you understood. So now you see in general, the body is in motion. The body is in motion in general. So immediately when the problem is given to you, the body is in motion, then your imagination should start. Your brain should start. You should before your mind's eye you must get the picture. What picture? Oh, body is in motion. ಅಂದ ಕೂಡಲೇ ಒಂದು ಚಿಕ್ಕಿ ಒಂದು ಮಾಸ್ ಒಂದು ಟೈಮ್ ಆಮೇಲೆ ಒಂದು ವೆಲಾಸಿಟಿ ವೆಕ್ಟರ್ ಬರೆದವು. ಬಾಡಿ ಈಸ್ ಇನ್ ಮೋಷನ್ ಅನ್ಕೊಳ್ಳಿ ಇಷ್ಟು ಬರೆದವು. ಫೋರ್ಸ್ ಈಸ್ ಆಕ್ಟಿಂಗ್ ಅನ್ಕೊಳ್ಳೆ ಫೋರ್ಸ್ ವೆಕ್ಟರ್ ತೋರಿಸಿ. ಫೋರ್ಸ್ ಈಸ್ ಆಕ್ಟಿಂಗ್ ಅನ್ಕೊಳ್ಳೆ ಫೋರ್ಸ್ ವೆಕ್ಟರ್ ತೋರಿಸಿ. ಹೆಂಗಪ್ಪ ಹೆಂಗೆ ಹೇಳ್ಯಾರ ಮುಂದೆ? If they say force is along velocity like this, if force is opposite of velocity, ulta. Okay, force vector ತೋರಿಸಿ ಬಿಡು. ಫೋರ್ಸ್ ವೆಕ್ಟರ್ ತೋರಿಸಿದ ಕೂಡಲೇ ನೆಕ್ಸ್ಟ್ ಏನಪ್ಪಾ? ನೆಕ್ಸ್ಟ್ ಏನ್ ಮಾಡ್ತೀರಿಪ್ಪ? ಓಕೆ, ಅದಕ್ಕೆ ಇಮಿಡಿಯೇಟ್ಲಿ ಒಂದು ಆಕ್ಸಲರೇಷನ್ ವೆಕ್ಟರ್ ತೋರಿಸಿಬಿಡು. ದನ ವೆಕ್ಟರ್ ಬರಕ್ ಶುರು. ಆಮೇಲೆ ಅವ್ರು ಹೆಂಗೆ ಹೇಳ್ತಾರ ಅಂದ್ರೆ at time t2 what happens? So are you applying force from t1 to t2? Yes, then it will be accelerated. Acceleration will not change from t1 to t2. At the end of t2 velocity will be more. Okay. End of the story. And you should know this is a story. पहला राजा आया, वो आया, ये आया, ऐसा ना हमारा कहानी कैसे शुरू होते है? बॉडी इज इन मोशन, पॉइंट डालने का, ये डालने का, ये डालने का, बोलो अब क्या होता है? फोर्स इज एक्टिंग. चलो ऐसा हो जाए. स्टोरी उधर तक और आगे क्या? I will remove the force at time t2. ठीक है? Body will continue to move with same velocity. Now what you have to now say is, now when you saw the carom board, okay, when you saw the carom board, okay, that is you saw the carom board. So you had the striker, okay, and you saw that the striker was moving with some velocity v bar. Okay, you saw that the striker is moving with velocity v bar, and this carom board was smooth. Okay, and this you noticed at time t1. At the time t2, the striker is here. The striker is here. Okay, so what will you do? The striker is here. What will you do? What will you do? ನಾನು ಮಾರಿ ನೋಡಬಾರ್ದ. ಸಿ ಇಲ್ಲಿ ವೆಲಾಸಿಟಿ v ಬಾರ್ ಇದ್ರೆ ಇಲ್ಲೂ v ಬಾರ್ ಬರೀ ಈ ತರ ಹೇಳ್ಬೇಕ. ಏನ? At time t2, I did not see the carom board is smooth. So I told the striker is there. ನಾನು ಮಾರಿ ನೋಡಬಾರ್ದ. Sir, draw the velocity. Velocity is not changed. Hello?
Yes, sir.
Now from this point onwards, the carom board becomes rougher. Okay, then if I show you the striker here at this point, right, at time t3, what are the vectors you will show? So you will show the velocity. So here it is v1 bar, then you will show here v2, then you will show here v1 bar, then here you will show v2 bar. What else will you show?
So force vector
Excellent.
opposite.
Force vector opposite to this. This is the friction. And what else will you show? Excellent. You will also show the acceleration. Acceleration vector. Acceleration vector will always be in the direction of net force. So you will show the acceleration. Got it now?
Yes, sir.
Sir,
This one. Now.
sir, I have a doubt.
Lego.
Sir, I have a doubt of the previous concept of the concept of force towards the opposite direction. ಇವಾಗ ನೀವು ಡಿಫ್ರೆಂಟ್ ಟೈಮ್ ಇಂಟರ್ವಲ್ಸ್ ಅಂದ್ರೆ t1 ಮತ್ತು t2 ಕೇಳಿರಂದ್ರ it can be any time like hours ಇಲ್ಲ minutes ಇಲ್ಲ seconds.
ಇರ್ಲಿ. ನೋಡ ಅದ ಅಲ್ಲೋ ದೋಸ್ತ ನೋಡ, ಈಗ ಇದು ಯೂನಿಟ್ಸ್. ಈಗ ನೀನು ಟೈಮ್ ಈಗ 1 ತಾಸು ಅಂದ್ರೆ ನೀನು 1 hour ಅಂತ ಬರೀತಿ, 60 minutes ಅಂತ ಬರೀತಿ, ಇಲ್ಲಿಕ್ರ 3600 seconds ಅಂತ ಬರೀತಿ. ಎಲ್ಲ ಸೇಮ್ ಹೌದಿಲ್ಲ? ಹಳೆ ಎಲ್ಲ ಮಗಳ ಗಂಡ ಯೂನಿಟ್ಸ್ ಆರ್ ಡಿಫ್ರೆಂಟ್. ತಿಳಿತ ದೋಸ್ತ? ನೋಡಿಲೆ, ಈಗ ಇಲ್ಲಿ ಇಷ್ಟೇನಪ್ಪ 2 inches ಅಂತಿ, ಇಲ್ಲಿಕ್ರ ಇದು 5 centimeters ಅಂತಿ, ಎರಡು ಸೇಮ್ ಹೌದಿಲ್ಲ? Units are different. Units are different. But it is okay. See, here I am not discussing the units. I am telling you instants of time. Instant of time T1, instant of time T2, like that. Okay? Did I answer your doubt?
No, sir. My actual question was different. Different intervals and hours nangu T1 to T2 ಏನೋ ಆಗುತ್ತೆ ಸರ್. ಇಫ್ ಇಟ್ ಇಸ್ ಅವರ್ಸ್ ಅಲ್ಲ, ಅದಕ್ಕೆ ಡಿಫರೆಂಟ್ ಅಪೋಸಿಟ್ ಸೈಡ್ ನಾಗ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಮಾಡಿದ್ರೆ ಮತ್ತೆ T1 to T2 ನಾಗ ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್ ಆಗುದಿಲ್ಲ ಸರ್?
ಅಂದ್ರ T1 to T2 ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್ ಅಂದ್ರೆ ನಮ್ಗೆ ತಿಳಿಲಿಲ್ಪ. ಈಗ ಅಲ್ಲೋ ಸೆಕೆಂಡ್ ಅಲ್ಲ
ಇವಾಗ T1 to T2 ಎಷ್ಟರ ಟೈಮ್ ಇಂಟರ್ವಲ್ ಸರ್? ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಮಿನಿಟ್ಸ್, ಸೆಕೆಂಡ್, ಅವರ್ಸ್, ಡೇಸ್.
ಹೌದು ಕರೆಕ್ಟ್.
ಸೊ ಇಫ್ ಟೈಮ್ ಇಂಟರ್ವಲ್ ಜಾಸ್ತಿ ಐತೆ ಅಂದ್ರೆ ಅದ್ರ ಜೊತೆನ ನಾವು ಕೋರ್ಸ್ ಅನ್ನು ಜಾಸ್ತಿ
ಇಲ್ಲ ಈಗ ಕೇಳ. ಈಗ ನಾನು ಕೇರಂ ಬೋರ್ಡ್ ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡಾಗ ಕೇಳ, ನಾನು ಟೈಮ್ ಸೆಕೆಂಡ್ಸ್ ಒಳಗೆ ತಗೋತೀನಿ. ಆಯ್ತಾ? ಈಗ ನಾ assume that I have got a big road, 100 kilometer road, which is smooth. ಅವಾಗ ನೀನು ಟೈಮ್ ಮಿನಿಟ್ಸ್ ಅವರ್ಸ್ ತಗೋ ನಡೀತೈತಿ, ಗಾಡಿ ಹೋಗ್ತಿರ್ತದೆ, ಹೌದಿಲ್ಲ? ಅವಾಗ ಈ ಕೇರಂ ಬೋರ್ಡ್ ಒಳಗೆ ಸೆಕೆಂಡ್ಸ್ ತಗೊಂಡು ಕೆಲಸ ಮಾಡೋದು. ಈಗ ನಾಳೆ ರಸ್ತೆಗೆ ಬರೋದು 100 kilometer ರೋಡ್, ಅವಾಗ ಅವರ್ಸ್ ನಾನು ಡಿಸ್ಕಸ್ ಮಾಡೋದು. ಆಯ್ತಾ? ಈ ಕೇರಂ ಬೋರ್ಡ್ನಾಗ ಸೆಕೆಂಡ್ಸ್ ತಗೊಂಡು ಮಾತಾಡಿದ್ರೆ ನಮ್ಗೆಲ್ಲ ಅರ್ಥ ಆಗ್ತದೆ. ಅವರ್ಸ್ ತಗೊಂಡ್ರೆ ಬೊಂಬಡ ಹೊಡಿಬೇಕು, ಹೌದಿಲ್ಲ? ಈಗ ನೋಡಿ ನನ್ನ ಹೈಟ್. So I can express my height in feet or in centimeters. Okay? Hello, no? Hello? Yes, I can also tell my height in kilometers. Any problem? No problem. Hello? Understood? No? See, now somebody's height is 2 meters. So what is your height? 2 meters. What is your height? 200 centimeters. Who is correct? Both are correct. Hello? Yes, centimeters. Okay. Or you get now 2000 millimeters something, my height. Correct? You are correct. Understood? Yes, sir. But then it is foolish to tell in millimeters. Centimeter ಅಥವಾ feet correct ಐತಿ. ಇಲ್ಲ ನಾ ಕಿಲೋಮೀಟರ್ ನ ಹೇಳ. Then you will write 2 into 10 to the power of -3 kilometers is my height. ತಪ್ಪೇನಿಲ್ಲ, but foolish. So you should use appropriate thing for appropriate. Isn't it? ಈಗ ನಿಮ್ಮ ಮನೆ ಒಳಗೆ ಈಗ ಸಾರು ಹಾಕೋಬೇಕು, ಸಣ್ಣ ಚಮಚದಾಗ ಹಾಕೊಳಕ್ ಬರ್ತೈತಿ. ಓಕೆ, ಕರೆಕ್ಟ್ ಸೈಜ್ ಚಮಚದಾಗ ಹಾಕ್ತಿ, ಹೌದಿಲ್ಲ? ಈಗ ತುಪ್ಪ ಬಡಿಸ್ಬೇಕಾದ್ರೆ ಸಣ್ಣ ಚಮಚದಾಗ ತುಪ್ಪ ಬಡಿಸ್ತಿ, ಸಾಂಬಾರ್ ಬಡಿಸ್ಬೇಕಾದ್ರೆ ಸ್ವಲ್ಪ ದೊಡ್ಡ ಸೌಟ್ಲಾಗ ಬಡಿಸ್ತಿಲ್ಲ, ಅದು ಉಲ್ಟಾ ಮಾಡಿದ್ರೆ ಏನಾಗ್ತದೆ? ಸೊ ಯು ವಿಲ್ ಯೂಸ್ ಅಪ್ರೋಪ್ರಿಯೇಟ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ಸ್. ಅಂಡರ್ಸ್ಟುಡ್ ಋತ್ವಿಕ್? ಈ ಕೇರಂ ಬೋರ್ಡ್ ಅಂದ್ಮೇಲೆ ಸೆಕೆಂಡ್ಸ್ ಮಾಡಿ ಅವರ್ಸ್ ಹೋಗ್ತಾರೆ. ವಿಲ್ ಡಿಸ್ಕಸ್ ಟುಮಾರೋ. ಇವತ್ತು ಏನ್ ಮಾಡೀನಿ ದಯಮಾಡಿ ನೆನ್ಪಿಟ್ಬೋದು. ಮನೆಗೆ ಹೋದ್ಮೇಲೆ ಸಮರಿ ಶೀಟ್ ಬರೀ. ಈಗ ಸಮರಿ ಶೀಟ್ ಬರ್ಬೇಕು. ನಾ ಏನೇನ್ ಹೇಳೀನಿ ಪಟ ನೆನಪು ಪಡ್ಕೋಬೇಕು, ಬರೀ. ಮನೆಗೆ ಹೋದ್ಮೇಲೆ ಫಸ್ಟ್ ಕೆಲಸ ಅದನ್ನ ಮಾಡ್ತೀರಿ. ಅಂಡ್ ನಾಳೆ ಬಂದ್ ಕೂಡಲೇ ನಾನು ಕೇಳೋಕ್ಕಿಂತ ಮುಂಚೆ ನೀವು ವಾಲಂಟಿಯರ್ ಆಗಿ ಸರ್ ನಿನ್ನಿನ ಕ್ಲಾಸ್ನ ಸಮರಿ ಹೇಳ್ತೀವಿ, ಐ ವಿಲ್ ಟೆಲ್ ದ ಸಮರಿ ಆಫ್ ಯೆಸ್ಟರ್ಡೇಸ್ ಕ್ಲಾಸ್ ಅಂತ ನೀವು ವಾಲಂಟಿಯರ್ಲಿ ಎದ್ದು ಹೇಳ್ಬೋದು. ನೀವಿದ್ದಷ್ಟು ಸಮರಿ ಹೇಳ್ರಿ, ಐ ವಿಲ್ ಟೇಕ್ ಯು ಟು ದ ನೆಕ್ಸ್ಟ್ ಲೆವೆಲ್. I will teach you different types of forces. Then I will teach you pressure also too. But you should tell the summary. Will you?
Yes, sir.
And you should volunteer to do. You should not wait for me. You should say, sir, I will tell ಅಂತ ಕೈ ಎತ್ತು. ಎತ್ತಿರಿ ಎಲ್ಲರೂ? right.